The universe is expanding. That much is confirmed. What is not confirmed is whether the expansion will ever stop, or what it will ultimately do. Approximately 68% of the total energy content of the universe exists in a form we cannot directly detect, cannot explain, and cannot fully characterize. We call it dark energy. It is the dominant component of the universe, and its primary observable effect is that it is pushing space itself apart, causing galaxies to accelerate away from each other at an ever-increasing rate. Dark energy was not discovered until 1998, when two independent teams of astronomers studying distant supernovae found that the universe was not merely expanding, but accelerating. The discovery was so unexpected that both teams initially assumed they had made an error. They had not. The confirmation changed our understanding of the universe's ultimate fate entirely and introduced a question that remains unanswered. The current leading model treats dark energy as a cosmological constant, a fixed property of space itself that does not change over time. Under this model, the expansion accelerates indefinitely, but never becomes catastrophic. The density of dark energy remains stable as the universe grows, and the result is a slow, eternal expansion that gradually isolates all structures from each other, but does not destroy them. But there is another possibility the available data cannot exclude. If dark energy is not constant, if its density increases as the universe expands, then the expansion rate does not merely accelerate. It grows without limit. It eventually overcomes every force in nature, one by one. Under this scenario, the universe does not end in cold stillness. It ends in total destruction. Cosmologists call this the Big Rip. The timeline of destruction unfolds over billions of years, but the final stages compress with terrifying speed. The expansion first overwhelms gravity at the largest scales, and galaxy clusters break apart. Then, individual galaxies dissolve as gravity can no longer hold their stars in orbital paths. Then solar systems disintegrate, planets unbound from their stars and flung into the void. As the final moments approach, the timescale of destruction collapses from billions of years to millions, to thousands, to days. Hours before the final singularity, the electromagnetic force holding atoms together is overcome. Molecules break apart. Atoms are stripped of their electrons. Minutes before the end, the strong nuclear force, the force binding protons and neutrons inside atomic nuclei, is exceeded by the expansion rate. Atomic nuclei rupture. Matter itself ceases to exist in any form. The universe does not fade. It is torn apart at every scale simultaneously, with nothing surviving. The Big Rip is not the favored model among cosmologists. Current observational data is more consistent with a constant dark energy, but the data is not precise enough to rule out the alternative. Dark energy has only been studied for a few decades, and its fundamental nature remains almost entirely unknown. Whether the universe ends in quiet, cold equilibrium or in violent, total annihilation depends entirely on the behavior of a force we do not understand and cannot directly observe. The answer is already determined. We do not know what it is,